So basically I have an iPad here that you guys are not able to see right now. See, this is the iPad which I'm using for recording the class, okay? So I'm only recording myself and the board. So whatever I teach, you should not worry about taking notes, okay? Because everything from the class is recorded for you, which you can watch later and revise, okay, if you forget something. But during the class, your full focus and attention should be for following the concepts, arguing with me, questioning me, doing some problem that I'll ask you guys to do. So that will be our goal, okay? And anyways, after the class, I'll upload the video of the class on YouTube and send the link in the WhatsApp group, so you will have it. I'm not a YouTuber as such. It is these videos are only for my kids, okay? That is you all. So in today's class, we are just starting a fresh batch, okay? So this is a fresh batch. We are starting from today, and we are going to, in this class, this is called level 2, where we will learn the concepts of 6th, 7th and 8th grade in 1 year. So basically by the time your school year gets over, you all will know all the concepts for 6th, 7th and 8th, all the 3 grades, okay? So if I'm starting with something lighter, don't think that I'm going to keep it only for that grade, okay? Alright?
Yeah.
So now let's see what we are planning to start. So I had put this that we are going to talk about variables and expressions and then rates and percentages. Variables and expressions, and then we'll talk about rates and percentages. So can somebody tell me what is your understanding of what is variable or expression?
Like what's an expression is?
What's an expression, or what do you mean by variable? I mean, just give me some very simple definition of it, okay?
Okay.
Or how you understand. Think of me as a 5th grader or a 5-year-old child, okay? And if you have to explain that to me, how would you explain that to me? Manas, yeah, strawberries are not needed. Yep. Yeah, Karen, go ahead.
An expression is just basically an equation without the equal sign. Basically.
Okay, yeah. Manas, what is your understanding of expression? What is expression?
I haven't learned it, but like when I think about it, I think about basically what she said.
Okay, so now look at this. I'm flashing something on the screen right now. Look at this, look at this, look at this, look at this. What are these? These are expressions without any output. We call it emojis, right? These are expressions which doesn't have any output. If I keep on now sending emojis to you guys, there's nothing that we will learn. There'll be no output for us in the class. So that's how you can relate it to a real life situation. If I'm talking about an expression, I'm talking about something like this. If I'm saying 5 plus 3, I'm just saying 5 plus 3. I did not mean anything actually. There is no output. If I put like this, 5 plus 3 equal to 8, then this is equation. There is an output. Yeah, like Caroline, what you explained, right? These two numbers added gives me this output. When you are representing the whole thing, that is called equation. When you have an equal to sign, that's an equation. When you don't have an equal to sign, this remains an expression. Is that okay? Manas, does it make sense? Yeah? Okay. Now, but life is not so easy like what you are seeing right now. Now we are actually dealing with a real life expression where we have something that we know, 3 will remain 3 for the rest of my life, but this is something that is new. X is something that is not known. This could have a value of 5, this could have a value of 25, this could have a value of 1 million, this could have a value of 5 billion also. Meaning something that's value can change. they are called variables. So when you are dealing with a situation or an expression where you have some knowns or constants or some variables together, this is a most practical example of an expression where you have variables and you have some constants. Yep. Is that making sense? So now another lame example is, let's say you guys join the class and I'm smiling here, okay? You guys keep looking at me, I keep looking at you. You are just seeing my expression, very happy, sad, angry, upset. Just an expression, I'm not doing anything. If I stand like this, keep giving you guys different expressions, there is no outcome. There is nothing that you guys will learn out of it. There is no equal to sign. That's a practical, real life example. So when you are dealing with expression, there is no output. If you are just dealing with my expression, me not teaching you guys anything, no output. Yep. So that's the basic difference between expression and equation. Now, let's look at some problems, okay? Or I will hold on to that problem for now. Let Ayush also join. He will be a little late, but once he joins, we'll talk about that. Ayush is one child who had given me some problems relating to expressions. And we will solve those problems. But till that time, let's deal with a little bit. So now we are talking about, we just touched upon what is an expression and what is an equation. And we also tried understanding a little bit about variable. Variable, something that could vary. Yeah? Like we say, this is edible, meaning you can eat this. Variable, something that could vary, something that could change. Yeah? That's the basic English. Now, where do we use or why do we use variables in the equation or in any mathematical problem? Any idea that you guys want to share with me? Why do we use or where do we use variables? Any example?
It's like an unknown amount. Like when you don't know how much of something, you use it.
Yeah. Something that is unknown and you want to figure out what exactly is that. Or situation where you are dealing with some clues, like a treasure hunt. You are not given a point blank information. You are given some clues and you are trying to decode that clue to find out the answer. Okay. So Manas knows how old I am, but Caroline probably doesn't know. And Caroline says, okay, fine. Let's see, how old is the teacher? You asked me that question, okay? And I'm not wanting to tell you exactly how old I am. So I told you, you know what? Caroline said, okay, how old are you? I said, okay, you tell me how old are you? So Caroline, how old are you?
13.
13. So when you gave me your age, I said, okay, you know what? I am 7 years more than 3 times of your age. I'm 7 years more older than 3 times of your age. So I did not tell you exactly what is my age. I told you my age is 3 times your age plus 7, or 7 years more than 3 times of your age. Now can you tell me how much it is? Okay, I did not give the right equation. I made myself 3 years younger. Okay. So Caroline, what was your guess of my age based on the calculation I was talking about? 7 years more than 3 times of your, let me say it right, 7 times more than 3 times of your age. 7 years more than 3 times of your age.
7 is 3 times. Wait.
I just wrote it down. 7 years more than 3 times of Carolyn's age. So again, this it had nothing to do with your age or my age. I was just giving you guys a practical or relatable scenario. Okay, yeah. So like what Manas did. If you look at the message box, right? What Manas did was he said, okay, 3 times of Carolyn's age plus 7. So I said 7 years more, meaning something plus 7. 7 years more than 3 times of Carolyn's age. So let's say Carolyn's age is X. X times 3 plus 7. This is my age. Okay. Now, if I say my age is Y and your age is X, so 3 times of X plus 7. So X is Carolyn's age, this is your teacher's age. So what do you say? Okay, now I know what is Carolyn's age. So 3 into 13 plus 7. 13 3 is 39 plus 7 46. So here, whatever I told in English, that we could convert that into an equation form. Yeah? Am I making sense with her? Carolyn, Manas, everybody? And Carolyn, do you know what beta means? Child, okay? So you guys are like my child, okay? So, I mean, I have 2 daughters. My elder one went to college this year. My younger one is in middle school. So, I teach you guys like a teacher, but I treat you guys like a child, okay? So, that's how I will treat you guys. If I say something which sounds a little emotionally loaded, don't worry about it. It's just a father within me that wakes up at times, okay? Alright, so coming back to this one. Whatever we do here, this was more like a simplest form of a word problem. We read that word, we wrote that in the form of an equation, and then we solved it by evaluating it, okay, by giving value for the unknowns, and we could derive it. Yeah?
Yeah.
So, when it comes to math, now Manas will probably say that, okay, I'm getting bored because you have told this before. But there is a theory, there is a concept, there is an approach that I insist on. Okay? That is called RAN. R-A-N. And this is like my magic wand. Okay?
Okay.
Who wins the race? Who ran the best? Ran the best. Who wins the race? Let's say you're in a track and field event. Who wins the race? Who ran the best, right?
Yeah.
Now, what R stands for? R stands for read. Read, read, read and read. A stands for analyze. And N stands for Nike. What does Nike say? Just do it. I say keep RAN in mind, because if you are wanting to compete and win, it will depend on how best you ran. Meaning, if you have a problem to solve, where it is applied, if you have a problem to solve, be it a word problem, be it any kind of a problem, okay? Read the question once, twice, 3 times, till you are confident and tired of the question, okay? When you read a couple of times, the question will become a little easier, lighter for you. Once you have read the question a couple of times, you are clear about what this question is asking, then you put your brain to task, analyze. Now you're thinking, okay, this question was asking this, I have to find out this, and I know these formulas, or this is my approach. So you are making a blueprint. You have not touched your pen yet. Okay? And if you have touched your pen, it's only for doing some scribbling, not for solving the problem. And then comes an Nike, which says just do it. Meaning, if you have read the question enough, you have already analyzed or made your plan, then just do it. Now, short form of this is, in summary, what I'm trying to convey here for you guys is, if you are solving any math problem, don't jump onto solving it. Read it first, think about it, think about your plan, then you do it. It might sound like I'm guiding you guys to waste a lot of time, but that is not the thing. I'm not guiding you to waste time. I'm actually telling you to avoid wasting time in the wrong approach. If you don't think you had a problem to solve, you started from here, you went this far, and then you realize, oh, I did not do it right. You start from here and then you are doing an iteration. This wastage of time that you will incur otherwise without thinking about your approach is what you can save by investing maybe 20 seconds more. Okay? So that's why you will hear this from me very often, not because I'm trying to bore you guys, but to re-emphasize that always solve problems in a more structured way. You can maximize your chances of doing better. Okay? Alright? So this was on the basics of expression, equation, and then my most boring concept of RAN. Now let's look at some problems. Let's try solving some problems. I have got some problems that I got from one of the students. I will just pick up one. Yes, Manas. I cannot. You're saying something, Manas?
Oh yeah, I was talking to my dad.
Okay. But you can hear me and you can see the video, okay, right?
Yeah.
Okay. All right. So let me pick up one problem, one sample problem, and then we'll look at it. There is a question which says, Mary borrowed $68.40. Mary borrowed $68.40 from her sister. Mary borrowed $68.40 from her sister. She will pay her back an equal amount each week. She will pay her back equal amount each week for 6 weeks until she has paid back all the money. She will pay equal amount every week for next 6 weeks until she has paid back all the money. How much money Mary will pay her sister each week? Did you guys hear the question?
Yeah.
I'm applying the same RAN technique, okay? Mary borrowed $68.40 from her sister. She will pay her sister in 6 weeks by paying her an equal amount every week. The question is, how much money she will pay her sister each week?
For how many weeks?
6 weeks.
Oh. So. So basically this is dividing, right?
This is divide. Yeah. So Caroline, do you agree that this is a simple division problem?
What?
Do you agree that this is a simple division problem? Yeah.
Yeah.
Okay. So I will not waste your time It's very simple. I mean, it was more like a jump start kit, okay? I just got you guys started with the simplest of the word problem that was shared by one of the students. So it said that somebody borrowed some money, it has to pay in 6 weeks by paying equally, you just divide by 6. That's how you get it. Now, I'm picking up another problem which is little loaded than before, and we'll see again. This is a word problem and we will apply our basic understanding of the equation, expression and whatnot and see how we are going to solve it. Let me read this question for you guys one more time. Mr. Frank packs pecans into small containers to sell at the local farmers market. Mr. Frank packs pecans into small containers to sell at the local farmers market. He has a total of 18.1834 pounds of pecans and puts them into packages with 1.5 pound in each. How many packages can Mr. Frank make? I'm reading the question one more time, okay? Read. Mr. Frank packs pecans into small containers to sell at the local farmers market. He has a total of 18.34 pounds of pecans and puts them into packages with 1.5 pound and in each. How many packages can Mr. Frank make? Did you guys get the question?
Yeah.
Manas, you got it? Okay. And trust me, I'm still toying with the easier ones. We'll look at little difficult ones and see how does that work. Applying the same concepts. Caroline, what's going on, beta? Are you able to try?
What did you say?
No, I was asking, were you able to try?
Yeah, but I don't understand the word. I didn't hear the question.
Okay, let me read it for you one more time, okay? So that's my basic principle, right? Read the question a couple of times, because when you read the question a couple of times, question becomes easier. Mr. Frank packs pecans into small containers to sell them at the local farmers market. He has a total of 18.34 pounds of pecans and he puts them into packages with 1.5 pounds each package.
Okay.
How many packages can Mr. Frank make? Manas, how far or close are we?
Wait, what was the question again? Sorry.
Okay. Mr. Frank
Yeah.
packs pecans into small containers to sell them at the local farmers market. Yeah. He has a total of 18.34 pounds of pecans and puts them into packages with 1.5 pound each. How many packages can Mr. Frank make?
Okay, so divide it. So, 18.34.
what's happening, Caroline and Manas?
It's hard.
Okay. No, I'm just asking what's happening. You guys have to tell me if you guys are stuck, there's something
Yeah, I'm stuck.
stuck. How about you, Caroline?
I think I got my answer. I just need to make it a mix.
What is the answer?
I got 25/2.
25/2? Okay. So, okay, can you explain me how you got that, Caroline?
And so you turn 18 3/4 into an improper fraction.
Okay.
And then that would give you
75/4?
I'll give you 75/4. And then you do 1/1/2, which is 3/2.
Uh-huh.
And you find like the common denominators. And then you like,
This is what you have to do, right?
yeah.
So, I will teach you guys some funny approach that keeps me excited when I do maths. So this one is math, right? When you have a mixed number, you use math for converting that to improper fraction, right? You guys know about it. Manas, you know about this, right? How to convert it? No?
I haven't learned this. I'm like a.
Okay. So here's the thing. If I have 1, 2, 3, 4, 5, 6, these are normal numbers, natural numbers, right? No problem. If I have decimal 1.2, 2.9, no worries. Yeah. If you have 5/8, 6/9, these are fractions, right? So far, no problem. When you have mix of it, look at the natural numbers, okay, decimals, okay, fractions, okay. Now natural number and fraction mix together, that is when you go mad. Yeah?
But the answer would give you like 13/4.
What is that? What is that?
3/1/4 would convert into 13/4.
No, don't go that way. It's not 13/4. So that is what I'm saying. When you have a mixed number, right, of some natural number and some fraction together, you use the math technique, multiply, add, divide. So if you have to convert this to 18/3/4, you have to convert that to a fraction. It becomes, you apply math. That's what I was saying. When you have mixed number, you go math, meaning multiply, add, divide. You start from here, multiply, add, divide, meaning 18/4 is 72 plus 3, 50. Multiply, 18/4 is 72, add 72 plus 3, 75, divide by 4. Okay? Yeah, you got very late. So I had picked up your problem, the problem that you had sent me. I am doing that one. So I did one of the problem, and I would want you to watch the video of the class, whatever we have done so far. Okay? That should help you solve it. Okay? So whatever problem you had sent, those are easy ones, provided you concentrate and not think about anything when you are solving it. Meaning, read 1 time, 2 times, 3 times, and then think about how you are going to do it, and then you do it. Okay, my RAM technique. So we are picking up second problem. So right now I'm just showing how to deal with this calculation. Okay. So when you have a mixed number, multiply, add, divide. 18 times 4, 72, plus add 72 plus 6, 75 by 4. This is the number of pounds that you have in the form of a fraction. Caroline said rightly that this is a mixed fraction, meaning, this is an improper fraction, meaning a fraction when your numerator is bigger than denominator, that's called improper fraction. When you're dealing with something like this, when your numerator is smaller than denominator, it's a proper fraction. Okay. So this is improper fraction, but doesn't matter. I don't care whether this is improper fraction or proper fraction. So from this we got this. So Mr. Frank has this many pounds of pecans. Now every bag is 3/2. Oh, sorry, one and a half. Let's convert this also into fraction. Mad 2 1 are 2, add plus 1 3 by 2. So you have this many pounds of pecan and every bag contains this much. Yeah? Manas, are you with me so far? Ayush, this is the problem that you have sent me, which says Mr. Frank has this many pounds of pecans. He wants to put them in bags and sell them in the local farmers market. Every bag is 1.5 pound. How many bags Mr. Frank can have? Yeah? So this was the total pecan and this is the size of every bag. We are trying to find out this much pecan can go in how many bags. So this became 75/4 and this became 3/2. Now I have fraction. One thing you guys can remember jokingly, that I have one best friend and his name is fraction. Meaning when I'm dealing with different types of numbers, I tend to convert everything into fraction, then my calculation becomes easier. Okay? So if I have a decimal, I have a fraction, I have a mixed number, I'll convert everything into one form, which is fraction, and then I can deal with them. Yeah? So fraction is my best friend. That's what I'm trying to tell Carolyn, and she will laugh at it. That how come a 49-year-old guy has fraction as a friend. Okay? So now, this much is the pecan and this is the capacity of every bag. So how many bags we can make? Obviously, 75/4 divided by 3/2. Yeah? Every bag can contain this many pounds, and this is the total pound of pecan that he has. Correct? That's what you'll do? Manas, are you with me so far? So this was the amount of pecan, this is the size of every bag. We are trying to find out how many bags we would need for filling this much of pecan. So this we converted to fraction with applying MAD, we got 75/4. This one also mixed number, we applied MAD to convert it to fraction. So we are trying to divide the amount of pecan by the size of bag so that we would know how many bags we would need. Now 75/4 divided by 3/2. Now there is a big problem. I don't know how to do fraction division. Too late to realize. I don't know how to do fraction division. Then, but I know multiplication, okay? I'm half a teacher. So I had to divide this fraction by this fraction. I don't know how to division, I converted to multiplication, okay? As soon as I did that, somebody got angry and flipped upside down. I converted this division to multiplication, this guy got super angry and flipped upside down. That's what I meant by I don't know how to do fraction division. Meaning you have a fraction division, you can convert that to multiplication and the number next to that flips upside down. Now you can do the calculation. Now look at the fun part of it. So 75 into 2 divided by 4 into 3. Now look at it. 75 I can write as 25 into 3. And I have a 2. This 4 I can write as 2 into 2. And I have a 3. What I have done is I have broken this into smaller numbers, okay? This is another fun thing that I do. I call it tic-tac-toe. Okay? So when you have big numbers to multiply, factorize them. 75 I can break this 25 into 3 and 2 is a small number, leave it like that. 4 I can break into 4, 2 into 2 and then 3. Now see, 1, 3 and 1, 3 tic-tac-toe. 1, 2 and 1, 2 tic-tac-toe. What do I have? 25/2. That's what your answer was, Carolyn? 25/2?
Yeah.
Yeah? So far you can see happiness on my face. I was enjoying doing this operation. I shamelessly said that I don't know how to do division of fraction, because I have a playful way of doing it. I can convert a division into multiplication by flipping the number next to it. Yeah?
Yeah.
And then when I got this, then I kind of split that to do tic-tac-toe. So far, no matter how tired I am after a day's work, when I get to this, I start enjoying it. That's what I want you guys to do as well. Yeah? Ayush,
Yeah.
Manas, Caroline, everybody with me? Is it making sense? Is it making sense so far?
Yes.
Okay. Now, there's one more concept that I want to touch upon. So today we looked at what is a variable, what is expression, what is equation, and Ayush will have to watch the video in detail with a peace of mind. And then the couple of problems that you had given me that I have solved, I want you guys to watch it and then try solving it by yourself. And then the remaining problems that you had sent me, I would want you to try again following the same approach and see if you are able to do it by yourself. If not, we'll deal with that again. Okay? Now, so today we just talked about expression, we talked about basic word problem, we looked at some simple calculations. We'll look at one more concept on percentage. We'll talk about percentage concepts, and then in the class day after tomorrow, we will get our hands dirty by practicing a lot of problems. Okay? Yeah?
Yeah.
So see, my simple technique is, first I will break down the concepts into very simple form. Like, if I have to open the garage door, I have to press a button. It's a skill. It's a memory that is with us. Same way, we want to learn the concepts so that it gets registered in our mind, and then we'll do practice. Okay? So that when we do practice, we'll play with that, and then apply that concept and see how easy it gets. Yeah? All right. Now, let's try to understand what is percentage. Who can explain me what is percentage?
It's like that,
I'm a 5-year-old, okay? Remember that. You have to keep it simple for me.
what was the question? It's like a dot, a slash, and a line.
Okay. That will not go well with somebody who had just gotten rid of the diaper, okay? I'm 5-year-old, that's what I said. Okay. How about Caroline or Ayush? Explain me what is percentage.
What? Something over 100, you would say.
Okay. Out of 100. Okay, let's see what Ayush wants to say. What is your understanding of percentage, Ayush?
What I understand about percentage,
Uh-huh.
what I understand about percentages is like, when you have a percent, it's like a grade, it's like, how much you got, did, or do something. And
Let me break it down for you guys now. Percent. Let's look at the English part of it, okay? If we know the English of it, we can decode it. Percent, okay? I will wait for Caroline to join back again. Just give her a minute. Okay. Let me remind. Where is... Okay. So per cent, per 100 cent, this is per, okay? $5 per pound. So when you say per, that is in the denominator, okay? So we are talking about per cent. Now this cent is nothing but a short form of century, which means 100. If any of you follow cricket or any game where we talk about century, century means 100. Yeah? Century years, 100 years. So when you're talking about per cent, you're talking about per 100. Now look at this. If I say, I will give you 10% discount. When I say 10% discount, I am saying, I will, see, let me write this English, okay? I will give 10% discount, meaning I will give 10 per 100 discount, meaning for every 100 I will give 10 discount. If I say 20% discount, meaning 20 per 100, meaning if something is $100, I will get $20 discount. 20% is 20 per 100. So if you're talking about 100, you're talking about 20 being reduced from it. If you're talking about 50, how much you're talking about? How much reduction we're talking about?
It's like 50%. 80% is like half of your original number or something.
Okay.
So you said that 100% means 100. So what?
Okay. So let's look at it. Now let's focus on 10% for now. I said, somebody told me that I'll give you 10% discount. 10% discount, meaning 10%. Look at this. 10 per 100. Meaning, if I pick up something which is priced at $100, how much discount I'm going to get? $10, 10% per 100. For every 100, I'll get $10 discount. Yeah?
Yeah.
If I pick up something which is $200, for every 100, I will get $10 discount. So there are 200s here. So I will get 10 plus 10, $20 discount. Yeah? If I pick up something which is $500, so there are 500s. For every 100 I am getting $10. So I get 10 plus 10 plus 10 plus 10 plus 10. This was discount. Yeah? For every 100 I am getting $10 discount. Yeah?
Yeah.
If I pick up something which is $50, how much discount I will get? It says per 100.
Okay, so
I don't have 100 right now.
you don't have what right now?
I'm sorry?
You said something you said I don't have.
I don't have 100. I was saying this says 10%, meaning per 100. For every 100, I'll get $10 discount. But right now, I don't have 100. I have only 50. So how much discount I will get?
Probably a 10%. So $10 off. So $40.
No. But see, if I'm buying something for $100, I'm getting $10 off. So I'm paying $90. If I'm buying something for $50, which is priced at $50, if I get $10 discount, I'm paying only 40. But this is not fair. Somebody is getting $10 discount after spending this much, Other person is getting $10 discount for spending less. This is not fair.
No, that's not fair.
Yeah? Ayush, do you agree? Or you don't?
Yeah.
So what is the solution then?
Probably give them the same amount. Like if one is paying 90%, like getting 10% off,
Mm-hmm.
which equals 90%. So probably the other one should also get like the same amount. Am I right?
Okay. So now I have a magic trick for this.
Oh.
This is simple. Now we will not use math, we will use English. Okay?
Okay.
Let's see. Let's try relating to that. 10%. Okay? 10%. This is English so far. I said cent is a short form of century, which is 100. So 10%. Right? Now if I say 10% of 100 is how much? 10% of. Multiplication is also called off, right?
Mm-hmm.
3 into 2, I can say 3 of 2. Yeah? So, whatever I'm saying in English, I'm just writing it down. 10% of 100. Let's see how much it is. This is my tic-tac-toe. 10 into 100 divided by 100. This 100 and this 100 I can do tic-tac-toe. 10% of 100 is how much? 10.
Yeah.
That's what we knew, right? The 10% means 10 of 100. So 10% of 100 is what? 10. Now, if I say 20% of 100, 20% of 100 will be 20 into 100 by 100. 100 or 100 we can do tic-tac-toe, 20. Yeah? And we will say, okay, for the 10% discount, for 200, something which is priced at 200, how much discount we were getting? Every 100, I'm getting 10. So I'm going to do 20, right? Let's see if 10% of 200 is how much? We know that 10% discount of 200 means there are 200s, every 100 I'm getting $10 discount. So I'm talking about $20 discount. Let's see, how much is 10% of 200? 10% of 200. Let's see how much it is. We know that it is 20, but let's verify ourselves. 10 into 200 by 100. Correct? Now look at it. 10 into 200, I can write this as 10 into 200, I can write as 20 into 10. Can I? This 200 I can write as 20 into 10. And this 100 I can write as 10 into 10. Is this okay so far?
Yeah.
Now time to play. This 10 and this 10 tic-tac-toe. This 10 and this 10 tic-tac-toe. How much it is? 10% of 200 is 20. Here we were saying 10% of 200 is how much? Every 100 is 10. I have 200, so 10 plus 10, 20. Calculation also we are seeing right now. Any numbers percentage if you have to derive, I will just write this as English. Yeah? So now I am saying, are you guys clear so far?
Yeah.
So now I am saying, how much is 10% of 50? Meaning I picked up something which is priced at $50. How much I have to pay if I am getting 10% discount? How much discount I am getting? Let's see how much is the discount. 10%. of 50. Okay? Now let's play. 10 into 50. These two are on the second floor, this is on the first floor. Yeah? Now 10 I will leave as 10. 50 I can write as 5 into 10, okay? Is that okay? This 50 I will take 5 into 10. Yeah? Is that okay?
Yeah.
Now this 100 I can write as 10 into 10. Time to play. This 10 and this 10 tic-tac-toe. This 10 and this 10 tic-tac-toe. What are left with? Only 5. What did we find? 10% of 50 is 5.
Yeah.
Meaning, now look at this. Is it not fair? When somebody with the 10% discount, if somebody is buying something for $100, he gets $10 discount. If somebody is buying something worth $50, he is getting $5 discount. Does it not look fair?
Oh no, it's not fair.
Does it look fair or it doesn't look fair?
It does not look fair.
It is fair. For $100 you are getting $10 discount. For $50 you will get half the discount.
Wait, what?
See, let's look at a practical example. Let's say Ayush and Manas went for buying something in the store. Okay. Ayush bought something for $100. Okay. Manas bought something for $50.
Yeah.
And there's a Thanksgiving deal going on. So the store says, I'll give 10% discount on whatever you buy. Ayush gets $10 discount because 10%, meaning 10 for every 100. He gets $10 discount.
Into $5 discount for me.
Yeah. So it has to be less, right? If you're buying more, you'll get more discount. If you're buying less, you'll get less discount, right? If the storekeeper says, I'll give $10 discount to Manas also, then Ayush will be super mad, right? He will say, I spent a lot of money, then you gave me this much discount. This child has spent less money, so you are still giving the same discount. That is not fair.
Yeah.
So he gets this discount. Now everybody is happy. That if you spend more, you get more discount. If you spend less, you get less discount. It is based on the same math. So 10% of 50, 10% of 50 gives you a 5. 10% of 100 gives you a 10 when you calculate. So it's simple math. Now the shopkeeper is not biased. He is doing a fair math. So that is what I was trying to showcase here. Percentage, when you talk about percentage, you have to keep only two things in mind. Percent means how much per 100. And then when you have to calculate. Now if somebody says, let's say you went to a Nike store during Christmas and Nike says, I will give you 20% discount.
20% discount.
So you picked up something which was priced at $75. You're trying to figure out how much you have to pay. You're not paying 75 because you're getting discount. You have to pay less. How much less? How much is the discount? So 20% of 75 because you're getting 20% discount. 20% of the price. 20% of the price. Now you do the calculation, you'll figure out. Yeah?
Yeah.
So this is 20 into 75 divided by 100. Now look at this. 20 you can write this as 2 into 10. Or leave it 20 and then leave 75. 100 you can write as 20 into 5, correct? Yeah?
Yeah.
This 20 and this 20 you can do tic-tac-toe. What you have? 75 by 5. 75 is what? 15 times 5 is 75.
Oh.
Then this 5 and this 5 also you can do tic-tac-toe. $15. This is a discount. You are getting $15 discount for something which is priced at this much. Because you calculated how much is 20% of 75. And that is your discount. Yeah? Make sense? Ayush, Manas, did it make sense or no?
Yeah.
So now the next steps are that between now and the next class, which is day after tomorrow, Ayush, I want you to, all the questions that mommy has sent, I want you to try all of them and send me the steps that you're using for solving it, okay? Don't give me the answers. I don't really care about the answer. I care about how you are doing it, okay? Do it, and every problem that mommy has sent, you solve one by one and send it to me. I want to see which one you are able to do by yourself and where you are getting stuck, okay? So when I see you solve the problem, then I would know where the problem is and I'll be able to work on that. Okay?
So does that also apply to me, or is it just for you?
It's only for Ayush because he has given me some problems. But for you, I would the only assignment I have, Manas, is whatever we have done today, I'll send a video of the class in a little bit. You watch the video and then get your hands dirty. Try finding out some 15-20 numbers, random numbers. Okay, let me see how much is 15% of 20. Let me see how much is 35% of 79. Let me see how much is 40% of 2000. Let me see how much is 20% of 1 million. Yeah? Play with it. Okay?
So I need to answer these questions, or like
Just randomly pick any number and try finding out some percentage of it. Okay?
Okay.
So that when we come to the next class, we will muddle the water a little bit more. Okay?
Uh-huh.
All right?
Okay.
That brings us to the end of